4 people are playing a party game where they will either all win a prize or everyone will get nothing. 3 of the players sit in a line facing a wall. A is closest to the wall, B is behind A, and C is behind B, like this. D is on the other side of the wall. They are given party hats and told that there are 2 red hats and 2 blue hats, but they don't know who has which hat. Each of persons A, B and C can see only the hats in front of them, but neither their own hat nor any behind them. D can't see or be seen by any other person. If any person can definitively determine the colour of the hat they're wearing without guessing and then announce it, they will all win a prize, otherwise they all get nothing. If we assume that all of the participants are totally rational, want to win the prize, and they also know that all of the other players are also rational and want to win the prize, is it possible for the players to be certain that one can correctly announce their hat colour so that all of them will win the prize? Pause the video and have a go now. It is possible. The players know that there are only 2 hats of each colour. So if C observes that A and B have hats of the same colour, C would deduce that their own hat is the opposite colour. However, if A and B have hats of different colours, then C can say nothing. So the key to their success is that player B can pause for a while, knowing that C would speak promptly if they did know their own hat colour. If C is silent, B can infer that the hats on A and B must be different. B can see A's hat, so if it's blue, they know their own hat is red, and if they see A's hat is red, then they know their own is blue. There is no other winning strategy, so the other players know to stay silent, and it's guaranteed that they will win the game.